sharing of what we're currently working on for Subnet 52 Dojo. Quick introduction, Expo from Tensorplex, and we're based out of Singapore, and that's why we're not super active on novelty search because of time zones, right? Like it's 5 a.m. right now, and we generally like watch the recordings the following morning after it has happened. So yeah, so we have done quite a bit of like Bittensor related events in Singapore over the past 2 years. And first event was I think it was the first like Bittensor Asia meetup where Vitalik and Cons was present, and then the second one was during Token 2049 last year. And the most recent one was Super AI last month, where we exhibited as well. So we're planning to organize quite a big event during Token 2049 this year. So if you're interested, please stay tuned for more information. I think in bridge over to Bittensor, that helped to onboard quite a fair bit of liquidity onto Bittensor indirectly. And it peaked at, I think, around 50 million TVL. We're also running validators, trust minimize bridges to facilitate the liquid staking token. And just a quick history. So before we started Tensorplex, we were actually actively mining on some of these subnets. And yeah, we were one of the top few miners across a few subnets. And that was when we decided to start work on Subnet 52, because maybe before I jump into the backstory for this, I'll just give a quick intro to Backprop Finance, which is something we've built as well. It's a platform where you can trade subnets and also analyze them. So it's a very trader-centric platform suited for the broader Web3 audience, where you have like watch lists, leaderboards for you to track addresses, and there is a non-custodial wallet, so you could actually perform like a staking and unstaking on a mobile interface on an app, so you don't have to download a separate wallet to interact with Backprop. So yeah, in the past couple of months, we've managed to rack up more than $500 million worth of transaction volume, and in total, it's more than 200,000 transactions that we have helped to initiate through Backprop. So yeah, back to.
I'm gonna do that. I'm gonna do that annoying
Mhm.
thing that Cons does and like jump in with questions.
Sure.
Only for the betterment of everything. Can you just quickly, before you move on, because having a mobile app where people can swap or stake is a pretty big deal. Can you tell us a bit more about like how easy it is or how people can get it, this kind of thing? Like and like, does it integrate with Talisman, or just so if people want to start using it, how could they do that quick?
Sure. Yeah. The beauty of this is that we designed this as a progressive web app. So what that means is that you're able to just go to your browser on iOS or Android, and then if you click in the settings, there is an option for you to save the website as an app, so it appears on your homepage. And if you click on the Connect Wallet button in this web page, you're able to sort of bypass the need to use another wallet. So there is an option for you to save, to generate a private key locally, and then it will be saved and encrypted in your own storage, your local storage, so that if you want to access it, you have to type in your password. And this this is a much better user experience, and we do plan to improve this even more. So, especially for traders who would like to optimize for speed, they're able to perform like transactions very easily in the future. So we'll share a bit more on that. But this is a non-custodial wallet like solution that's built on top of Backprop natively. So there isn't a need to use like another wallet. So maybe I could share a bit more about like how we came why we called this Backprop. So this is more like a fun fact. We call this backprop finance because it's named after this term in ML called backpropagation. It's a key step in training a neural network where you calculate like the error based on the output and the predicted output and the actual output, and then you propagate the error backwards so that the you could use the gradients for updating of the weights. So if you think about the entire Bittensor network, it's kind of like a three-layer neural network where the validators, miners, subnet owners are in the first layer, and then the subnet alpha is essentially represented in the second layer, and then the output layer represents the value that the entire network is generating. And by staking and unstaking onto these subnets, you effectively adjust the weights of the neurons and the second layer. And that's why backprop finance, the interface, is kind of like the backpropagation step for the entire Bittensor network, because you get to set weights across all of these different subnets, which leads to like second order effects, like how much emissions the teams, the miners, the validators are receiving. So yeah, that's backprop.
Well, I never thought of it that way before, but that's exactly a perfect analogy.
Yeah, because
Thank you.
yeah, I think in general, like if we think about the tensor as a network, like you would need some feedback mechanism to allow it to continue to grow, and the financial interface is kind of like the best way to optimize the training process. And yeah, that's how we decided to call it like this. And yeah, let me go back to our story. So
Yes.
when we were mining on the some of these subnets, we often noticed that it was hard for some miners to push state-of-the-art models or services further, because the miners are incentivized to converge to what the validators are capable of validating, especially if they're using like some form of a model. And if you were to create like a model that's more powerful than what the validators are capable of validating, or even if it's not properly defined in the objective function of the subnet, then it's very likely that you will get penalized. And we thought that the best way to address this was to introduce some form of human feedback into these scoring mechanisms. But this was a challenge for the subnets to do it themselves, because it was an entirely new set of problems that the team had to tackle. And we thought like maybe instead of doing it for every subnet, why not just abstract this away as a service where we essentially act as the human feedback layer that all subnets can tap onto in order to complement their validation mechanisms. So this helps us push the state of the art even further, so that we're able to create models and services that are powerful enough that could compel users from, or even like the broader AI ecosystem outside of Bittensor, to pay further attention into what's going on here. So yeah, Dojo is a platform where we crowdsource human feedback that we could use to train, fine-tune AI models, improve AI pipelines, validate subnets, and also in the future, we do plan to provide like a human API in agentic frameworks. So we'll talk a bit more about like all this like later after we explain some background on what we're trying to tackle. So there are three core components of AI. So if you want to improve AI, we'll need algorithms firstly. So it's like it could be the architecture of the neural network. Could be things that we use like reinforcement learning or reasoning. And then secondly, we need compute. And last but not least, data. Where if we want to advance AI, we'll need to improve any one of these three or a combination of these three components. And based on a study in 2022, it was projected that we will run out of data to train models sometime between 2026 and 2032. And also as platforms are increasingly locking down their content, now you have to sign in to access videos or tweets or Facebook posts. So it's becoming much harder to access these data sets. So there are some subnets that are tackling this, but I think the question now is like, what will happen if we run out of data sets? So I want to stress that this was a can't zoom in here, but if you squint, you could see that it's research published in 2022, and it's very clear today that we're probably at the point where we've hit some sort of a data limit. As if we look at the models that are published recently, a lot of the advancements are mostly attributed to the technology, which is like reinforcement learning. And there is still like there is still potential for data to be one of the like critical contributors to the advancements of AI. It's just that we've kind of hit like a local maxima, and therefore like we'll need to feel the need to continually scale the data component by synthetically generating data sets. And the issue with synthetic generation of data set is that we need to use these data sets responsibly in order to avoid model collapse. So you can see in this example here that, given a model is trained on a corpus of pictures of dogs, and then if we use the same models that we train to generate synthetic outputs that we use to continuously train the model, it's going to lead to a corrupted output here in the middle, where you could it's basically the biases of like all the iterations just compounding to the point where the final outputs of like this iterative training cycle doesn't resemble anything in the training data set. So that's why you need human validation to ground the different synthetic data sets generated across multiple iterations. And this is where I want to briefly touch about RLHF. So RLHF is a technique. It's reinforcement learning with human feedback. It's a technique where you improve a neural network through using like human feedback to align the model towards what exactly users are looking for. So that is how products like ChatGPT are made possible, because if you take the pre-trained model without any RHF, and then you try to use it, it's not going to sound very it's not going to respond properly. It would respond as if it's trying to complete your what you're trying to say instead of responding to your message or your question. Because the LLM is pre-trained to perform next token prediction, it needs some form of like fine-tuning in order to reach a point where it's able to get like an output that users would expect. So yeah, this is just some background and a very high level architecture of how our subnet works. Is that, oh, by the way, if there are any questions, feel free to ask along the way.
I want to, before we go into how the subnet works here, Darwin, just understand like the core premise. I think it's the core premise of Scale AI, right? Like if you talk to, what's his name, Wang? I believe his name's something Wang. At Scale AI, they got recently bought by Facebook. He would say that, Alexander Wang, there it is. He would say, and he said this a while ago, he said, all you guys are trying to create synthetic data, but you'll never be able to beat my moat, which is just that I create human feedback. I actually create data sets from humans that label data sets, and we can extract human preference. You know, in the previous slide, you're talking about these like dogs, right? Like, okay, we'll train a model on dogs, and then we'll use the model trained to produce dogs to generate more images of dogs. And basically, if you do this a number of iterations, it's sort of like inbreeding, and you get this weird Cookie Monster shaped dog that no one wants except Sister Ciensis. The premise here is that we will always need some sort of labeled data. Can you like hone into that a little bit more? Like, why is that the case? Why can't we just get better at producing synthetic data, and one day humans are no longer needed?
Yeah, for sure. So when it comes to training a neural network, you would need to give it an objective function. So there would be cases where you could train a neural network without any human labeling, but that is only if you could run some form of simulation and give it a very clear like way to score how the model is performing. And this, unfortunately, can only happen in very limited domains, like, for example, AlphaGo for the game of Go, or potentially like some maybe in code generation where you're able to perform a simulation in the code execution environment.
Where you can verify if the code runs.
Yeah, so that's the limitation with your like reinforcement.
What's an example of a type of problem, or like an objective function, a hierarchy that requires human labeling to really achieve or like perform well on it?
Yeah, so one example would be the one in the slide where it's hard for you to simulate like programmatically a way to define what a dog should look like. It's generally something that could also be subjective, where it depends a lot on like what the users prefer. So there are cases where
Right.
things might appear to be like correct to the software, but like to the humans, we know that this is not the most intuitive way to present some form of information, and that is where you need like some form of human feedback.
So it's it's kind of like, you know, we can't define a dog other than pictures of dogs, right? Because the objective reality is the final arbiter of whether or not something is a dog. and that requires just collecting data from reality. Or, for instance, human preference, like something like this is nice to read, or this image looks good. You can't create a synthetic version of something that is so like it comes from the objective world. It comes from human preference. It comes from humans directly. You can't create a synthetic version of that.
Or
Exactly.
you can,
So,
but it's not like you can create a synthetic version, but you can't create the original human data. Like it sounds to me like that's the nucleus of synthetic data is real data, human data. Like if we're talking about something that would be subjectively decided by a human or something like that, like kind of like yeah, and then how Const aptly said, like the inbreeding that can happen if there's no fresh input. Does that kind of make sense?
yeah, exactly. So I think there are cases where letting the models run a bit loose with like, generating or hallucinating would be useful for maybe exploring creative ideas. But it's impossible for you to let the AI models reach an output or like converge to an output um, without some human like grounding it. Like, what is to say that this image that's generated here is actually like the image of the dog in the last column? What is to say that like this is good or bad? Like you definitely need some human interpretation of this, because the angle of like all these models are meant for humans to use, right? So unless we're training for like some other entity to use this AI models, then we'll have to get feedback from that entity instead. But in this case, it's all a human-centric development. Yeah.
Yeah, because kind of at the end of the day, this might be a little antiquated, but the AIs don't really know what they're talking about, or the models or the LLMs. They just are interpreting what we've explained to them, right? Effectively. So, and then finding patterns within that, from my understanding. So I've always loved Dojo. The human in the loop. It's so cool. It's so refreshing, right? In its own way too. So, yeah, it makes sense to me. I love it.
Yeah. So, just a very high-level overview of what's going on. So firstly, the user would be either a subnet or an AI developer that would require some human labeling tasks. And these tasks would be sent to Dojo in the form of a dataset or a pipeline. So a pipeline is like an AI model with some prompts, some databases to generate the prompts, and next the datasets and pipelines are then integrated into our synthetic data generation platform, where we'll collect human feedback for these created datasets. And if the models are provided, in the future, we do plan to support some form of online ROHF, where the model can be improved at the same time as the data generation process. Thirdly, we'll then end up with a set of curated synthetic data that the user can use to improve their model. Or if the AI model is already provided, then the user can then update the model in their pipeline. So this results in an improved model or service for the end user. So the question now is like, where exactly does the feedback come from? So going into the subnet mechanism, the validator is responsible for generating the tasks through the synthetic API, where we have some way of seeding the prompts, and then we'll run it through an augmentation process, which we'll describe a bit more later. The same validator would then generate a series of outputs, and it would be sent to the miners for rating. So the miners would receive a set of multiple outputs, and they'll have to do some ranking based on their interpretation of what is good or not. So I'll perhaps share my screen, and then you could see an example of this in action. So what you see here is the synthetically generated prompt given a certain use case, and the users would then have to.
Sorry, Darwin. I don't think
okay,
we.
Let me know if. Okay, that's fine then. Then I'll just go back to.
If there's screenshots, Mars is suggesting that, but it sounded like we were going to go live. So of course, the screen share is not working.
Yeah. Let's see if this works. Can you see the Dojo platform?
No, I don't think anybody can. So what you might want to do here, Darwin, is simply take a screenshot and chuck it into the chat. Or if anybody else can see it, they could do that for you. But it's just unfortunately not coming through from Singapore.
Okay, sure. Second.
Or can you pass us through a URL, and then perhaps we can direct people to see it themselves?
Yeah, sure. I have a link.
Oh, cool.
So this points you directly to the demo. So you could you could interact with the different outputs, and then you're able to rank the output based on its similarity to the prompt, and how visually appealing it is, and how interactive are these outputs. So these are this is just an example of like the type of tasks that we could support. So if you click on the demo page in the link, you're able to interact with quite a few other modalities, but I'll just jump back into the slides, and then we'll continue to talk about the subnet mechanism. So feel free to give the demo a try, and then
let me just break in here and see if I can understand a little bit what's going on, because it's quite impressive. We have this website over here that is running a whole set of different. These are environments generated by Kimi2, given the particular prompt. So at the very top, we had a prompt that said, create a self-contained interactive Duolingo style educational quiz for grade school students that teaches the concept of data packets, tidy bundles of information. So Kimi went and then generated each of these tools. Is that correct? So like we're looking at like Kimi2, 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 and Kimi2. These are 4 different implementations of the same thing. Is that correct?
Yeah, exactly. So what the validator has done is that they generated a synthetic prompt, and then they made a few adjustments to it. So it could be positive adjustments or negative adjustments, and then correspondingly an output is created for these prompts or instructions. And the goal here is for us to gather what types of augmentations we can do to a task like this in order to generate something that's most visually appealing, or like that is most like attractive to a user. So this is where the miners would come in, and they would have to interact with every element of this generated interface. So they'll have to try to answer the questions in the right manner, in the wrong manner, try to break things to see like which one of this is the best overall interface, and then rank. After ranking this, we'll collect that data set, and then we'll be able to use this to fine tune an even better model.
Okay, so that's really interesting. So because I'm always wondering how do you create a task where we know that a human is actually going to label, right? So it's one thing to say, okay, great, we're going to get the human labelers to register minors on Bittensor, but how do you validate that? How do you know that it's actually human labelers? So this is the crux here. So you give a really difficult task. I want to generate this like matrix style data pack design, but all four of them are given a different prompt. And is it so some of those prompts have actually removed features from the design, like, okay, don't make it pink, make it black and instead of pink. And so the users actually have to evaluate this like interactive environment. And they have to be able to detect that this is the one where the prompt has been like messed with. Is that right?
Mm. Yeah, exactly. So the biggest issue with collecting ground truth from the miners in an open manner is that we actually need to find a way to validate it because we actually don't have the reference. So that's why we have to perform augmentations. In this case, we call it perturbations. So slight like changes to the prompt in a positive or negative manner, because we're able to get the relative ground truth for these prompts and outputs that are negatively like augmented. But we know for sure that if we try to reduce the quality of it in a very like obscure manner that couldn't be detected by an LLM, then the humans will most likely rate the yellow prompt here as like something that's worse than the green one. And then if we continue to perturb this further, the red one's going to underperform the yellow one. But we don't know the exact score of it because this would be a subjective thing for the humans to provide their like absolute numbers. So one of the challenges would be that if we try to augment the prompt to improve the quality, there could be a case where the corresponding output might be worse than the original prompt. So that's why you see here there is a range that we assume the score of the output, and that this is valuable information because we can kind of build an understanding around how these augmentations, these positive augmentations, would be helpful for a given type of task. Maybe for generating like a science experiment, you want the prompt to be written in this way, and then for something that's more like a game, you want it to be written in another way. So these are things that we could select, and then we will validate the miner's performance by adjusting the prompts in a negative manner. So this is the partial ground truth.
Right. Okay. So this is really very interesting because this is the crux of how the mechanism works. And like starting from the beginning, let's build a design where we want human laborers to label things better or worse seems like almost impossible. But it's based on this idea that that it's only a human would be able to detect these subtle changes, subtle disimprovements in the outputs generated by an LLM in a complex prompt. And why is that assumption made? Why is that assumption made? Like why can't I just hook up a VLM to the screen here and look at these video, there's these like little animated games and detect that this is indeed incorrect. Like, why do we make that assumption? Why does it have to be a human?
Yeah, you can actually use operator agents or models to try to read the code of this generated outputs, but there would be points where you would struggle because a lot of these augmentations can be in a form where it requires some interaction with the base and then analyzing the effects of the interaction. So for example, if you were to drag a slider and then um, the dial on the slider doesn't follow the cursor fast enough. So these are small like things that you would notice as a human very easily. But for a text-based LLM to not even a text-based LLM that reads the code, but even for a visual-based LLM, like it's hard for them to pick up this kind of things because this happens in the temporal domain. So there aren't like that many capable like open source models that could perform like such analysis across this coupled with like interaction on a user interface. So these are essentially like the gaps that some of these models are currently facing, like the broader open source models and closed source models are facing. And we know that there is an opportunity for us to generate tasks that involves such modalities.
And
Yeah.
Darwin, right now we're looking
So
at video. We're looking at like a game generation, but is that the only domain that this works with, or is it really the broad spectrum of different problems? Like the dog labeling, obviously, is probably not a good one because you could just solve that with a VLM. Is that right? Like
yeah, exactly. So
or
it's very likely that the types of tasks that we're generating would involve multiple modalities. So you can imagine in the future, like a lot of these interfaces um, would be a bit more immersive. So it would come with like sound. It could be in 3D. Um, there would be like other elements. We could tie in like images that are generated by other subnets, and then we could put it in the interface. I think this is something that we've just started exploring. Like we haven't gone into the route of like creating a hyper immersive, personalized user interface that like people would spend like their lives in the future. So these are these are like this is just the first step. Like if you look at the outputs of Lovable, of like Vercel, like the generative application platforms where you could easily create user interfaces, websites. They currently exist only in the form of a dashboard or like a landing page. Like it's very easy for them to create landing pages and dashboards because there are so many samples of this out there on the internet. But what about for games, for science experiments, for things that we could potentially plant into use cases like in education, where you will want to improve the rate at which you teach students, maybe some physical concept, and you would need to be able to accurately represent all these um, physical, like all these concepts, so that you're able to properly teach like the students as well. So there are like a lot of potential ideas we could be exploring. If we have the ability to generate user interfaces that are out of distribution that we don't see like today.
Amazing. I, you can see the next. I can see the next slides, and I can also see Sidhant's questions, which I think are gonna. They're gonna. There it is. There's the mechanism. So, and I was playing with this demo. It's really cool. But I noticed, it's an EVM wallet that I'm connecting and stuff like this. So this is a good transition because my question was going to be how do people get mining? How do people engage with the API?
Yeah. So the goal of one of the goals of Dojo was actually to make it as easy as possible for anyone to come in and participate in this ecosystem, because generally, like, for someone to mine on a Bittensor subnet, they need to have some technical competency. But that would mean that we lose the access to the broader like community of users that are non-technical. And we've always wanted to find ways to involve these users, because they would bring valuable information that is still useful for us to train the state-of-the-art models. So we built this platform for miners to collaborate with labelers, so that they're able to mine without the need to set up a miner. They could just log in with the API key that is provided by the miners, and everything is all done through the website. So they don't have to set up the server. They don't have to deal with like all the Bittensor stuff. So it's abstracted to a platform here. So
sorry to interrupt you. So you're actually reducing the friction by pairing labelers with miners. Like the miners don't have to even go find labelers. You connect them.
Right now, the miners would have to find or like connect with the labeler. So it's not like a marketplace where you could just pick the labelers you want to work with. It's more of like a platform where if you already have like people that you could tap into to perform the labeling work, then all you have to do is just to set up the API keys for them to log in via this platform. So this is just one option to join the Dojo network. There are also decentralized ways for you to enter. So you could run your own miner, run your own infrastructure, because there will be miners that are keen to scale this by perhaps automating some parts of the labeling workflow. Maybe use as much AI as possible, and only require humans to step in whenever like needed. So that is also like very possible through the decentralized option, where they just take the miner and then they add whatever infrastructure that they want to do. So we have spoke to some of the miners, and we know that these guys have operationalized their setup in different manners. So maybe I could just quickly share about the state of like the miners today. So right now, like it's there are like groups of miners that have consolidated, and these miners have industrialized their operations. So in Vietnam, there is a team that is basically hiring part-timers from schools. It could be like part-time students, or it could be fresh grads, where these guys might not have like the good like employment opportunities, and for them, this is like a viable way to make some money. So the miners there have sort of turned this into like an operation where they pay these participants for the task for every task that has been completed. And then the Chinese guys, like some of the miners from China, they have created this very complicated like AI pipeline that minimizes the amount of like human intervention as much as possible. But the issue with like some of these tasks is that you still need like humans to solve it, or to at least validate that the answering workflow is properly working. So they still have like humans that are they're working on their customized interface where they could quickly screen through the outputs of the models as they scan through different parts of the code bases, and they have their interfaces as well to replicate like what you are seeing on the Dojo demo page. So yeah, there are like other groups of other smaller groups of miners that are coming in like once in a while. But in general, like the goal for us eventually is to find a way to distribute the excess of mining on Dojo to as many people as possible, because this would be one of the ways for the community to get to steer AI towards the direction that they want to see. So yeah.
That's really interesting. You
So
have
there
both.
is
You have
Mhm.
industrial teams hiring hundreds, thousands of people to come and play this game, and you have synthetic and human teams at the same time. You also have like symbiotic teams, you might say, that are also contributing and competing. How many? Is there any way for you to peer into how many people that in total are participating here and mining on this network?
It's hard to get the actual number of like humans that are participating in this, because it depends on how much some of these miners are willing to sort of outsource to human laborers or to AI. But we have been speaking to some of these miners, and we know that they have a labor pool of like hundreds of miners each. So like cumulatively, like if we were to scale up our subnet to tackle maybe like 10 more modalities tomorrow, we should be able to tap on to like at least a couple of hundred human labelers.
Brilliant.
So for the next version of the subnet mechanism, this is something we've recently implemented. It's the rich human feedback feature where we collect text feedback on top of preference score. So earlier in the example that I shared, the tasks were revolved around collecting ranking, just scores of like what you would think each of these outputs deserve. In this current version, which is already on mainnet, we're actually collecting this text feedback that is then used to generate a new output. And this is inserted back into the labeling task for the miner pool. So you can imagine that if you're working on some of these ranking, would then be given this option to enter text feedback as to how you would like to improve the best output. And this allows us to collect iterative, rich text feedback that could lead to even better synthetic data sets. And also it could be used to train reasoning models, because you get to peer like directly into how the human labelers are thinking. Like, what exactly are the issues that needs to be resolved? What are the ways that we could introduce like some improvements? And you can imagine like in the future, like a lot of these reasoning steps could then be planted into a separate model to help with the orchestration of generating a new output. So the goal here is for us to collect ranking, text feedback, and then we'll run it through a generation cycle. Then we'll generate a new set of outputs, of which then we'll collect the ranking and text feedback, and then we'll do this continuously until we reach a point of convergence where the miners think that there aren't any more things we could do to increase the quality of this output, maybe due to the limitations of the model, the task, the prompt. Yeah, so that is the end state that we want to collect, because that is useful for training a new, like training the model that created these outputs, and also training a separate model that could take all these reasoning steps and then potentially automate some of this as well in the future. So these are some potential tasks that we could gather rich human feedback. And I wanted to show an example of how we could interact with the interface. Maybe I'll just share a link and you can take a look. So
I'm liking these local demos.
So this is where you're able to interact with this interface, which is meant to simulate basketball physics. So it's just trajectory motion. And if you try to play with this on your browser, you would realize that or like some, features that could be improved on. Like for example, if you drag the basketball, if your cursor goes over the window on the top left, the trajectory stops moving. So it's not very intuitive. There are also like some features that are not ideal. Like for example, there is some noise or like animations that is a bit disturbing at the bottom. So these are things that you could put into the text box, and then it will be sent back to the data generation pipeline where we would improve the output given the feedback, and then we'll generate this new output for miners to rank, and also to continue providing feedback on as well. So this is how we try to implement some like iterative cycle. And right now we're tackling the user interface domain, but I don't see how we can, scale this into all the other modalities in the future.
And the prompt, because at the top of that image, there's a show more. So when we open that, is that prompt, is that essentially is that what the users are asking for and the miners are helping give?
No, that's the validator. The validator generates that.
Okay.
Right, Darwin? Yeah.
Exactly.
Yeah. And so the user gives the feedback, and then the next stage would be the LLMs generate the same game with that feedback, and the humans then have to label it again. So you get this multi-stage RL environment where you can train a model via multiple steps on actually improving the game that they're playing, right? So it's not just single, like one-shot implementation of the game, but you can take the data to generate incremental improvements upon already existing code.
Amazing.
Yeah,
and with
exactly.
this enriched,
so it's
with this enriched human feedback too, it's like people are saying why they're making decisions. and you're able to pull that out and, like you're saying, bring in the reasoning. That's really, really cool.
Yeah, exactly. So it's an iterative process. So you could imagine that there are multiple paths that this could take. So this is like it's like a tree structure where you would start with a single prompt, and then multiple miners would be able to provide their feedback. And these outputs would then be compared against each other, and we'll take augmented outputs, and then we'll get the miners to then generate another maybe like 4 outputs for both of these augmented outputs, and then we'll be able to continue like augmenting this in whatever direction that the crowd prefers. And you could imagine that there could be like so many different types of outcomes where maybe like there is one that's optimized for accuracy, there is one that's optimized for interactiveness, there is one that's optimized for education. So those are things that would help us collect useful synthetic data. Yep. So yeah, I think yeah, I briefly talked about some of the miners on Dojo network, but just some numbers. There are more than 1.5K registered accounts via our centralized Dojo platform API. But these days, it seems like a lot of the miners have chosen the decentralized option. So we are not seeing that many registrations on the Dojo platform already, because they have already like optimized their own user interface or their own workflows. And we've generated more than 160,000 code bases since we started. And this by itself is already valuable data sets for training code generation models, because you can easily take this and run like some fine tuning, or even like use this to pre-train a code gen model, because it's very it's data set that is very clean. Like it's there is a lot of like curation that we're doing in order to validate that it's working before the user sees this on the interface. So yeah, the chart that you see here on the right are just data points that we collect from the miners on some of our validators that we're logging. And it's only in between March to July this year. And just from that alone, we've collected more than 10 million labels. And we think it's way more than that, given that we've only logged this specific subset of labels and tasks. So what do all these numbers mean or translate into? Given that our synthetic data pipeline has generated a lot of UI code bases, we've decided to fine-tune a model in this domain to prove the value of the data set that we're collecting. So we took an existing model, which is the Quen 2.5 coder instruct. It's a 7B model. And while it's strong in coding tasks in general, it struggled with generating complex interfaces. So given all these prompts, if you can tell, like the original one on the left, it's actually not as good as the ones that were trained on the Dojo synthetic SFT dataset, which comprises only of the code bases that we synthetically generated. And then the one on the right is the Dojo human feedback DPO model, where we took the human preferences collected from the miners and we ran this process called direct preference optimization. And it is only with the human feedback that we gather from the miners, we were then able to generate a substantially more visually appealing output. So yeah, the craziest thing about this is that it not only just led to an improvement in the user interfaces that were being generated, it also helped the model generalize across other domains. So we've done a bit of benchmarking and yeah, with some of these benchmarks, and we saw that there were some improvements that were made despite the data set that we use. It was constrained specifically to interface generation tasks. So it's a sign that potentially we, with the
But it performed worse on math. It performed worse on math. I think that says something about the human labelers, right?
yeah, perhaps. Yeah. Yeah, maybe
But
it's
everything else. So
its ability to do math. Yeah.
Okay. So there's a lot. It's a lot here, Darwin. I mean, because I'm looking at this this example you have in the slides here. People should go visit this link, the one I put, the Tensorplex AI Dojo interface coder, and go see the actual animation just halfway down that document. And so the one on the far right, I think this may have been lost on people. So here's an image of that. What that image is. The one on the far right there, that like sort of more like high fidelity, like particle effects. That's the one that was generated by doing, and that's a LoRa on top of Quen trained with a DPO. So that's direct policy optimization, which means that we're like literally just training on what is it? Like we're using the actual reward given by humans and the code, right? So we're taking the model, we're generating some code, and we're using the reward signal from the labeled data set from Dojo, correct?
Exactly. So DPO is a process where we take two different outputs from a given prompt, and then we'll get the users to compare which one is better. So it's a binary 1 or 0 for the two outputs. And then this would be used to, this would be fed into the actual training process as compared to the other like methods like proximal policy optimization, where you would still have to train a model, like a reward model to steer Quen towards the right direction. So it's a direct way for us to inject human preference into the models, because we're able to generate the pairwise comparisons from the information that we collect from the miners. Because when the miners do the scoring, they do it by ranking it from 0 to 10. And then we know that if the miners were to rank like one output as like maybe 8, another output as 6, we're able to feed this into the DPO process as we'll take the first one as 1, and the second one as 0 in DPO.
Is this, why did you choose that base model? Like why Quen 3? Or is it Quen 3 billion? Yeah, Quen 3 billion.
It's Quen 2.5. In general, the Quen models are actually very good. And there are some reasoning models released by the same team as well that were actually like the best to be built on top of. So we've actually done like quite a few fine-tuning processes on other models, and we realized that we've gotten the best results with Quen so far.
Would it be fair to say that this, in this domain that you guys have been focusing on, which is, generating these like animated games. Would it be fair to say that this is the best model in the world at that size, at 3 billion? Or even potentially better than, like, where does it stack against just models in general? And like, how good is this?
Oh yeah, specifically for generating interfaces at this size, I don't think there would be a model that would be better than what we have here. So that's something that we're quite confident on. But the question now is like, how are we able to generalize this to unlock even more use cases while keeping the parameter size locked at 7B? This is something that we like to do as well. We want to push the limits of like how capable we can with this 7B limit. Are we able to introduce more modalities as long as we improve the feedback that we're getting and the quality of the data sets that we're using to fine-tune the model? So that is something that we're looking into as well.
Yeah, I mean, I may be sneaking ahead of the slides here, but you know, an obvious one would be the creation of websites.
Exactly.
Right. I mean, like this, so that would be totally possible, right? With this design, in fact, it's like an immediate low hanging fruit would just be, you know, generate websites that look nice, that have all the features that people want, and host them, and you know, compete with, you know, V0 and Lovable.
Exactly. But I think given how we're able to generate out of distribution tasks, it's very it would be very possible for us to tackle more on the creative use cases rather than to just create dashboards, landing pages, and all that. We could create games, game interfaces, very, very complex, like interfaces that require like a very complex type of operations. That would mean like you would have a lot of like controls, and what's the most intuitive way of like handling this? I think this is probably where like this would be even more valuable because Livable, Vercel, and like some of these platforms, I think they are trying to tackle the general use cases, but for us, we have the ability to go to the extreme to test the absolute limits of like what an interface should be like. And it could also be hyper personalized. So previously I mentioned the education use case where we could theme the application, like the education application, and something that the student would be very interested in. Could be like cars or sports, where for them to play the game, they would need to understand the underlying concepts. And yeah, having an interface like this would help contextualize math and science problems while keeping the students engaged. So that is, I think, like one of the most exciting use cases that could be built as an application on top of the Dojo interface model.
Oh, wow. So you could literally have quizzes for schools, and that data, you know, could be made available for training. And
the children yearn for the mines.
Yeah, let's
Exactly.
let's yeah, it's not child labor, it's child labeler.
Exactly.
Yeah.
No, but that also any learning, like adult learning, this kind of thing, if there's whenever you have user feedback coming back, and just to bring it back, like that's what you're doing with backprop too, essentially, right? You have an interface, people can use it. are you like actively using Dojo itself, or maybe a private, like a separate spin-off of the technology to improve it, or yeah,
Yeah,
are you
one of the biggest like problems that we want to tackle is, are we able to collect passive human feedback beyond just incentivizing humans to provide feedback? Because if you think about a game, um, like this education app that you see on the left here, um, based on the way the students interact with this application and um, potentially how fast they learn, we might be able to build a better um, model, because we could do some form of A/B testing across all the different students that are trying such applications. And we could tie this back um, into Dojo by potentially generalizing this across to other use cases that would help us perform the A/B testing a bit more efficiently. So um, the end goal is for Dojo to act as like a way for us to gather A/B testing feedback that would be hard for us to explicitly mention something. Like, for example, the reason why they don't think this is the best user experience, or how they think a certain type of feature can be improved. These are things that you cannot collect passively. You could only infer through the way that they're interacting with these applications. So it's going to be like a synergy of both like passive and active feedback, human feedback that we collect in order to improve the models in the user interface domain. Yeah, so for the next use cases, we are currently partnering up with Subnets 17 and Subnet 44 on 3D generation and video analytics. So our miners would come in to provide human feedback to help improve their validation mechanism. So it's kind of like a multi-pronged strategy where they have their own AI validators, setting the baseline. And then if we want to further like refine something, or to capture edge cases where the validation mechanism hasn't accounted for, then the humans would be able to perform these tasks. Outside of Bittensor, we are currently speaking to a few partners in the robotics industry, because we see a huge gap for where human labelers and operators can help address. And we are solving a set of small robotics related tasks with a well-backed robotics startup partner who will handle the robotics side of things, since we're not experts in it. And then if this works, we'll continue to scale towards this direction, because I think there is a big opportunity for us here to make an impact. Yeah. So on the research front, there has been quite a lot of interest from academia in tapping onto our human labor pool, because one of the biggest issues with a lot of these outsourcing projects is that it was often not complete or not successful because there weren't enough contributors that could support this. And we think if we're able to incentivize some elements of this, we could eventually be able to complete some of these work that would be useful for the broader open source AI community. So yeah, that's some things that we're working on. And beyond the use cases, we are also thinking of like, the vision of like Dojo as a platform, because at the rate at which things are moving, it's very likely that we are not going to need to depend on humans to train AI, especially when like AI matches human level performance. So once the gap is mostly filled, it's very likely that Dojo would serve as a platform for human agentic collaboration by allowing agentic workflows to tap into the human labor pool to complete tasks. And then in the longest term, where AI is pretty much doing like everything, Dojo will then serve as a platform to align AI to human values and principles. So you're able to have a say in defining how AI should be like through the Dojo mechanism. So these are like just some visions that we have that we think Dojo can evolve towards. At the rate at which like everything is moving, it's honestly very hard to project things in like time frame of like years or even months, right? So we'll find like the best opportunities that we could tap into, things like robotics and potentially like whatever comes next in the future. That's something that we'll explore as well. So yeah, this is for now the guiding direction for our team, and basically the subnet. And yeah, that is all for Subnet 52. Just a very quick like run through of what's going on today.
What's the next model that we can train on Dojo, Darwin?
So what we're planning to do is we're going to take this model, and then we're going to further fine-tune it with the text feedback that we're collecting from the miners. So right now, what we're collecting is just the ranking scores, right? So these are preferences, but we think we can take this to the next level by adding by retraining the model with the outputs that are generated based on the reasoning that's provided by the humans.
What's the like the most applicable market for this data? Like, what problems in AI can only be improved with this type of human feedback labeling? And therefore, like, what model can you guys train that can really, capture a lot of attention and also potentially revenue for Dojo by generating?
I think in general, anything that's visually subjective would definitely involve would require some form of like a human feedback that we could incorporate into like a model to potentially process or grade, so that we reduce the reliance on like human labeling, because we can do some we could try to transplant some preference into that. So yeah, that could be in the video domain where everything is visual across the across the time axis, and in the robotics field, like what we mentioned here, being able to understand.
So we could apply this to video generation as well, like generate like human labeled data sets for that can allow us to train Soras, etc.
Yeah, so there are a few angles here. So one, we could support in the generation of like a world model, where we could get the humans to label whether, if given a certain action for a given state, the output is as expected. So a role model is slightly different from like an LLM, where it doesn't do like a next token prediction. It predicts the entire world based on the current world and its and a set of actions. So that, I think, we could potentially like rely on like human labeling to refine. And this serves as like the simulator for you to train robotics vision language action model, where you could then plant the robotics neural network into this world model environment for it to learn, to train its own specific use cases. The one biggest gap that world model will probably face is the human interaction element of it, whether if it's able to understand its like the social context. If you're standing right in front of a person, this person waves at you. How are you supposed to respond to this? This is something that robots would definitely need in order to be used in the real world, like standing next to each other. So that is one of the biggest gap that we could feel right now. And yeah, so yeah, just keep a lookout for the things that we're building.
Absolutely will. Wow, I mean, Darwin, fantastic. T-Slice, do you have any points you want to get in here?
It was such a great presentation, and you guys really got into the nitty gritty. And I'm always blown away by how brilliant the Tensorplex team is generally. And I actually got a chance to meet Darwin at Endgame. We've chatted since then, and every single time I come to him with something or we're talking about something, I just think differently after. It's an elevation always. So it's just such a pleasure to get such a deep dive into this subnet that is utilizing the human input and is bridging that gap, and then also working with the other subnets. I just think it's yeah, it was really great. Thank you so much. And I don't know if there's questions in the chat still.
I had a conversation with T-Slice as well, and I think, yeah, like it's always, I think what came out of that conversation was that, like, yeah, the blockchain is like the best place to experiment crazy ideas. And I think the Tensor serves as a good like for these ideas to happen. So I hope, like, everyone would be able to build something that could only be possible with like the subnets, the technologies on Bittensor, like EVM and all that. There is a possibility for us to create like our own parallel blockchain universe that's powered by agents from like Apex. Maybe the smart contracts can be audited by like Bitsec. So I'm really looking forward to see, like, things that like T-Slice could potentially be working on in the future as well.
They're experiments, and it's all fun and games until you create a space laser that is an unstoppable machine, which kind of looks like what you have right here.
The rate like at which the technologies are growing, like we're just increasingly becoming like our own like Oppenheimer type of experiments, and then hopefully we're able to suppress this in time.
Just make sure that it's not child laborers, but just child laborers.
Yeah. put that on my tombstone, right? But yeah, and just to further your point there, Darwin, and something that's just, I think, so important for people to think about in the Bittensor ecosystem is, like, what is the unique thing that you're unlocking with the subnet, and how it's leveraging the underlying Bittensor technology to bootstrap, and the classic example is bootstrapping compute, but which is people operating machines, servers, whatever, GPUs. This is bootstrapping human input, human labor, human labeling, human activity. So it's a really unique example of the incentive mechanism getting humans to do stuff, which is always fascinating.
Exactly. I mean, this is the only subnet on Bittensor that's aggregating human intelligence in its rawest form. Of course, like the miners on the other subnets, they do aggregate like intelligence, but those are refined intelligence, which is useful for like the use cases. But like in our case, we're tackling like a raw form of like intelligence that could be used to solve like one of the biggest like problems that like decentralized AI will face. How do we enable this recursive self-learning AI? And I think if we find a way to reliably gather human preference, human-generated data sets, we can then unlock the ability to create like something very powerful.
Amazing.
Beautiful. Thanks, Darwin. Everyone for coming. Let's end it there. Have a good night. I'm sure it's quite late for you, Darwin, so get some sleep. And T-Slice, thanks for co-hosting with me. Take care, everyone. Bye.
Pleasure. Thanks.
Great.
Bye-bye.
Thanks a lot.